All right, here's another couple examples. So number 7. So here, this is a tricky one because, you know, we have an absolute value equation. So we would think, okay, well, 5x minus 4 equals -6, right? Or 5x minus 4 equals +6. So we could think we could just break it up. The difference is, though, that we have absolute value here equals -6. And we talked about absolute value as the distance away from 0. And And so since it's a distance, it's always positive, right? If you remember from geometry, distance is always positive. And so you can't have a negative absolute value. An absolute value will never return negative, okay? And so whenever you have an isolated absolute value, there's nothing going on outside this absolute value, and it equals negative, your answer is going to be no solution. And that's why we explored that earlier. So we have no solution because this has a constraint on it, right? The constraint is, hey, this absolute value is always going to end up positive. It's always going to return a positive value. And so our answer is empty set or no solution. Okay. You could also write your answer like this, or you could just say no words, no solution. Right. So that's what happens then. But make sure it's an isolated radical. So make sure, in other words, there's nothing outside the radical. And if it equals a negative, then the answer is no solution. Okay. So I want to contrast that with number 8. So number 8, we do have an equation that equals a negative here. The difference is this absolute value is not isolated yet. So you can't just go and say it's no solution until you isolate the absolute value. Okay, and that's what we have to do. So just like if this were a variable, and we want to get it by itself, we're going to do the same thing with the absolute value. So we want to isolate the absolute value. Okay, and so what I'm going to do is I'm going to subtract 5 from both sides, right? Sadden up, so we want to subtract the 5 before we divide by 3. So then I'm going to bring down this -3. Don't forget about the negative. Bring down the stuff inside, the absolute value. And then we have -7 minus 5, which is -12. So now I want to get rid of this -3. So I can't just add 3 because this is attached, right? It's being multiplied here. So if I added 3, I would have to, PEMDAS says I would have to multiply before I could add or subtract, right? So adding 3 doesn't get rid of this 3. So what I want to do is I want to divide by -3. And then I have to do the same thing on the other side. So notice how none of this affects anything on the inside. I'm just dealing with stuff on the outside. So then what happens is I end up with the absolute value 2 plus 2w equals, and then over here, -12 divided by -3 is +4. So now this absolute value equation can work, right? Before it looked like it was going to be, like it was equal to a negative. But I don't want to jump to that conclusion until I isolate the absolute value. And now I can say, oh yeah, this is equal to a positive. And so we can split it up. We can say, all right, so we're going to have 2 plus 2w that can equal +4, or 2 plus 2w, this inside expression, can equal the opposite of 4, or -4. Okay? And then we just solve from here. So I'm going to get this w by itself, so I'm going to subtract 2 from both sides first. So I get 2w equals 2, and I divide by 2 on both sides, and so I get w equals 1 here. That's one solution. Now on the other one, I'm going to subtract 2 from both sides, so I get 2w equals -6. Now I'm going to divide by 2, so I get w equals -3. Alright, so those are my 2 possible solutions, and yeah, that's how it works. Let me know if you have any questions, and I'll see you in class.